All right, good afternoon. Welcome to part 2 of Daikin's VRV installation session or training we're going to do this afternoon. My name is Glenn Bradshaw and I'm product responsible for VRV, Daikin Air Conditioning South Africa. If I could just please ask that you ensure that your microphones are muted and that your camera is turned off at all times. And then what I'll do is I'll be stopping periodically and I'll be taking questions. So, welcome to this afternoon session. And as I said last week, in any successful project, planning is essential. If you fail to plan, then plan to fail. How much planning for this week's work have you done today? It's a question you should be asking yourself at the start of every week. How much planning have you done? And then this week's little quote: every job is a self-portrait of the person who does it. Photograph your work with excellence. That's unknown. Okay, that's somebody unknown. Right, we're going to start off this afternoon, and our first topic, we're going to look at sound and position of the unit. And the reason why we're going to start off here is because this is part of planning, and this is when you should be thinking about where a unit should be positioned and how that unit will affect the surrounds, the people that live around the unit. Okay, so remember that our VRV range are the quietest on the market, but that doesn't mean that it's not going to interfere with somebody. Okay, and remember that sound is something that is perceived differently by everybody. Okay, so my music that I play at home, to me is the way I like it, but I might find that my wife might object. She prefers the music played a lot softer. Okay, and my neighbors might start complaining as well on a Saturday night. So sound is subjective, and it's something that we need to consider. The same thing happens with air conditioning systems, and what might be quiet to one person might not be the same to a neighbor nearby. Okay, so let's have a look. Sound power is the energy of sound. Okay, in practice, it's not possible to calculate the sound pressure from the sound power. It's only theoretically possible from a point source. I'm going to just build that up slowly. The feeling of noise or sound pressure, air pressure fluctuations in the microbar area. So the way we perceive sound in our ears is by pressure, as that sound fluctuates. Okay, and that's the volume. And then it's measured in the decibel weighting, and the dBA is the value that is the correction for human perception of sound split into frequency bands. All right, so how does Daikin measure their sound? Well, real noise is always different from the engineering data books. So inside our engineering data books, remember we spoke about data books in the first session. Okay, you'll see that there's values given there for sound, and it's published in an anechoic sound room. That's a room with low background noise and no sound reflection. Have you ever seen one of these or been in one? You'll know that they've got foam padded walls that looks like egg crate type material. Okay, and this deadens out the noise so that you only get the noise from the unit. Okay, the units are in a fixed combination of 100% ratio. Okay, standard temperature conditions on a 5-meter pipe length, fixed compressor capacity steps. 5-meter pipe length for VRV, we know we can go much longer than that, but it's impossible to put that amount of piping into a sound room. Okay, so it's done along these guidelines to give us a starting point in which we can start measuring the sound of the unit. Okay, in the field, mostly there's reflection of sound. What does that mean? Well, we're going to build up on that now. Depending on the installation location, the feeding of the sound source can increase by as much as +8 decibels. That's quite considerable. Okay. If we take a unit that's, for instance, over here, that is installed, okay, in this type of arrangement against the side of a building, what this gradient, this blue gradient is showing us over here, change my pointer, okay, showing us over here is the sound as it moves away from the unit is gradually getting quieter. Okay, well, the sound pressure is reducing. Okay, so as you get closer to the unit, the darker blue gradient, you'll be able to hear the unit, and as you move away, gradually you will be able to perceive less and less of the sound. Okay, so As I said just now, we were talking about that sound. Most of the sound of what we hear, okay, is reflected. And here we see the first sound is back against the wall and then off to your ear over here. Then we have some sound that will come off of the unit and bounce off of surfaces in front of the unit and reach our ear. And lastly, we'll have some sound that will be direct from the unit to our ear. So there we see three ways that the sound arrives at our ear. Okay, and over here we can see that a wall reflection at 5 to 10 meters could be plus 2 decibels, and below 5 meters, okay, it's less than 5 meters, plus 5 decibels. Floor ground reflection, say off a tarmac surface, can be up to 4 decibels. Okay, so you can see there that the way we perceive most sound that we get is reflected, and this is why when we spoke about the archaic sound room, they take away that reflection sound, so they're dealing with only the sound that goes direct to the measuring point. Okay, so sound is very important to consider, and we've had many cases where units installed in areas have become problematic for this because consideration was never taken in the placement. Okay, so there are many ways that we can solve this, and some of the ways that Daikin have got. Okay. How can we reduce the noise of the outdoor unit? Well, we can find another position for the outdoor unit without direct visibility. Okay, when you're not in direct line of sight of sound, that does tend to take out quite a bit of the perception of noise. Okay, Daikin also comes with our units. It has an automatic or manual low noise during nighttime operation. So it's called low noise operation. This can be set up either automatically through the condenser, which it will look at the warmest part of the day, which is generally around 2 o'clock. It will add on a time period to that, and then you can set up starting times, say like 8 or 10 o'clock at night, and then it will switch off at a prescribed time the next morning, also done by adding on time. Okay, so it's not precise as a real-time clock, but it's done by adding on hours according to that. The other way is that we've got a low noise board. Okay. That board plugs into the condenser, and then by closing certain contacts on that board, we can initiate the low noise operation. Okay, so it's a more accurate way of doing it. Okay, but both of them work pretty well, and we've used them with success on many jobs. Okay, something just to remember when using low noise operation. Okay, remember that the unit has to go through certain functions. These functions cannot be avoided. For instance, the changeover sound from cooling to heating, that noise, the swishy noise you get through a four-way valve, that you cannot do away with. That's just part of refrigeration. Okay, so if a unit changes over from cooling to heating or back again during the night, that noise will still be there, and you will still hear it at the full noise as you would in any other time of the day. Okay, you can't block it out. There's also no limitation to the startup noise. Okay, and of course, anytime you start something at night, it's that bump in the night, you will hear it. Okay, so if you go from dead quiet to something starting, there will be something. And then, of course, units have to go through defrost operations when they're in heating. These are required as part of the operation to keep the unit operating efficiently and that you don't freeze up the outdoor coils. Okay, and also oil return functions are another important part. Oil return being that function that the unit goes through periodically in order to return oil back to the condenser. Okay, so these things we have got no limitation over, and when it goes into any of these functions, the unit will operate at full capacity for a short period of time in order to get that function out of the way. Okay, the other way of eliminating noise or sound problems is the installation of a sound wall. Right, so let's go through this and have a look at what we got. Here's our picture again. This time we're standing back a bit, and we can see this blue gradient moving away, and we can see that the gradient here is in a 90-degree, and basically the sound is breaking out in that quadrant over there. Okay, and about 30 meters back, you're getting about minus 20 decibels on there. What happens now if we take this unit and we move it to the top of the building, but close to the edge? Okay, over here we've got sound breakout, and you can see the light blue area. And again, you can see that down here we don't have much sound, but higher up we would. So if there were two buildings of similar height, this over here might be a problem for the building adjacent to this one over here. So it'd be a consideration that you'd need to look at. But if this was the tallest building in an area, this actually might be the option to go for, because the breakout is up mostly and away from the building and not going to affect the people that are living lower down. We could move the unit further back, okay, and over here you can see that this time now we've basically deadened all the sound problems around the side of the building. Okay, so moving the units around to get a better position can be one way of eliminating. Then we spoke about a sound wall, and because the considerations for a sound wall are things like height and also what the sound wall is made from. You can get pre-built up sound walls, which are louvers with sound deadening insulation in them, okay, or attenuation inside them. These do work quite effectively as well. And here we've got a wall of 2 meters, and you can see that from the gradient we've killed quite a bit of the sound, but as you go further back you may start to hear a bit of it again, because sound traveling in waves tends to arc away from the sound source. So back here you might start to hear things. If we increase the height of that wall over here, basically here we can eliminate most of the sound. Remember again with the height of the wall that this mustn't cause recirculation of the condenser air. Okay, so for a vertical discharge machine this might work better than it would work, say, for a horizontal discharge machine. All right. Isn't everything? Okay, it's always good to look at some pictures, and here we've got an installation. Both these images taken from the same site. So what you're looking at over here is this in the right-hand image over here. And basically what we've got here is we've got sound problems because it's in a confined alleyway, okay, and lots of hard surfaces for sound to bounce around. And the problem is that this person at the top here can hear the unit running down the bottom. What's happening? Well, we need to make considerations that first of all we've got a very good setup here for recirculation of air, condenser air, which means that the condenser may have to increase the fan speed in order to try and reach the target condensing or evaporating conditions, depending if it's in heating or cooling. And with that increase in fan speed, we generate more noise. And because this condenser over here would also be responding to what's happening from the condenser at the back. So once we create a situation like this, we actually create a knock-on effect, and the sound can continue and become worse as the unit tries to deal with the situation of its poor installation. So where we place units is very, very critical. Okay, not only from the sound aspect, but also from the operation. And if we do something that's going to be negatively affect the operation, it can cause a unit to generate more sound than it would need to under normal operating conditions. Okay, so over here we've got 2 poor installations. We've got ice buildup on this unit over here, okay, which is from snow. We don't see a lot of that around here, but you can in the colder climates up in the Free State and places like that. And I've seen around Queenstown, I've seen units ice up quite badly as well. Okay, something else, try not to place units in garden, dense garden vegetation. Okay, not only does it restrict the airflow, but also it invites all sorts of other creatures into the condenser, which can damage PC boards. Right over here, we've got fixed to that, and there's a snow hood put on the side of these condensers. This is just a bit of thinking that you might need to consider in order to make sure that the airflow is not restricted or hampered in any way around the units. Okay, just some considerations there. You can see that's just an image. This is generally from Europe. It might be something that you might have to consider. So if you ever do work up in the areas of Lesotho and things like that, it's not uncommon in those areas in the Eastern Cape and places like that where roofs have actually collapsed due to the snow buildup. Okay, right. Another problem, and this is something that we have on the coast. We have wind. When we place a unit, we need to consider that strong winds can blow units over. I've seen large VRV systems that are close on 300 kgs get blown over in Somerset West, and that caused the damage of compressors. This type of thing over here will cause compressors to become damaged because they'll pump away their oil and then eventually become mechanically damaged. So we need to consider how we're going to strap units down. A very good method is to actually go to the installation manual, and it will tell you to bolt down the feet, okay, and you would have to put it onto some sort of platform. If that's not available, you may have to use stay wires. Okay. Something else to consider as well is that the base on which the unit is on must be uniform and stable. In other words, uniform, it must carry the weight of the unit, the full weight on the width or the depth of the unit, okay? And over here, you'll see this point type bracket is not a good way of doing things. It deforms the base, it cracks the paint, and eventually you're going to get corrosion setting in there. Another consideration for placing of condensers is remember that in the cooler months when they're in heating, water will be flowing out of these condensers, and you must make provision to remove that water away from the building. Otherwise, it's going to become a safety and health issue. Safety because people can slip in it. Health because over time, algae and things like that grow in the water. And also, it devalues the structure of the building. Okay. All right, so drip trays underneath the unit is a good way of going. Right, when placing units down on a surface, you may not place them on springs. Okay, the compressors are already mounted on rubbers, okay, to take up the vibration from the compressor. Mounting it on springs is only going to cause a problem. Remember, with copper piping, if you continue to move it back and forth over a period of time, it becomes hardened and will eventually crack. Okay, so this is not a good way of doing things. So do not mount it on springs. You can mount it on Tico pads, okay, rubber Tico pads. Okay, there's that one that we see just now as a no-no. It's not okay. Or on some sort of surface that takes up the full weight of the unit. Okay, considering, okay, like a plinth, okay, something like that. Over here, for instance, that's incorrect. You need an incorrect mounting position. Okay, the full width of the foot of the condenser must be taken up by the supporting beam or plinth. Okay, so the unit must be mounted in a way that it's stable. And you will notice in the books that it does mention that the units must be bolted down. Okay, so like I said, we have had 300 kg machines that have been blown over in the wind. And that is a sure warning that if it's happened once or twice, it can happen many times after that. Something else about the installation of outdoor units that we need to consider, okay, is that we must allow access around the units for servicing. Okay, and as you can see over here, okay, this does not allow for good access to the servicing, for the servicing of the units. Okay, moving on from that, mounting or installing units in confined areas is not advisable. We must make provision for the air, the discharged air from the condenser to be moved away from the unit, and that it cannot be allowed to recycle and influence the unit or any other equipment that's in the room. During summertime, the garage will heat up and there'll be a shortage of capacity and cooling. And in the wintertime, the garage will become cold, and this will also reduce the capacity and heating. Okay, so there's just some considerations to make. These are common mistakes that we come across. And it's just something that the guys need to move away. Obviously, we know that it's very difficult from the installation technician, but it is something that project managers need to just negotiate a bit stronger. And that we're using units that are of the highest efficiency, and we mustn't do things that act against that efficiency. Okay. Good installation, view this one over here. Okay, and over here we can see we've got a mixture of units. They've put a fence around it. Obviously, that's for security and for safety as well. We've got free-flowing access air, both underneath the units and in through the side, and free discharge out the top with no chance of recirculation. Just a consideration, why unit air underneath? Well, it's not always necessary, but if you're going to put, say, for instance, a wall around this plant area, this wasn't a fence, this was a wall, what would happen is that we would tend to start creating a recirculation of air. And by allowing air in underneath, so we put grills along the bottom here, then we actually separate the two paths of the air, the intake and the discharge. And this is also being done successfully on a number of jobs. Okay, once we've negotiated with the architects and the people, and they've understood what needs to be done, they've accepted this, and it's actually made a huge difference to the performance of the units. Right, so when a technician receives a unit on site to install, a couple of things that he needs to have a look at. He needs to check that the nameplate is okay, so all the details in the nameplate are there. It hasn't been scratched off or anything like that. The casing is okay. In other words, we don't want to see casings that are dented and all that. If the unit's received like this, you need to report it. Okay, And also when installing units, we want to make sure that when they're placed from the transport on site onto the installation location, that they're not damaged in any way. Okay, and then also just check the internal piping and cables and make sure that nothing's come adrift and that everything is in the right place, no cables are snapped or piping is cracked. Okay, and just on the topic of that, from time to time we get guys asking questions about oil that they find in the drip trays, and the answer to that is that the oil that is often found in the drip tray is yellow in color. It's hydraulic oil, and sometimes it doesn't wash off from when they manufacture the coil. Okay, and it finds its way down there in the transportation from Europe to South Africa. So just when you see yellow oil, don't worry too much. If the oil is clear, then you need to start checking, because compressor oil is clear in color. Okay, so just something to keep your eyes open there. All right. Okay, so we've come to the end of that session over there. Are there any questions? Okay, everybody still there?
Yep. Yes,
Right.
I'm still here.
Thanks a lot.
Yes.
Okay, I can't see you, so I have to rely on your voices from time to time. All right, so we're going to go into session 2. Okay, session 2, we're going to look at at piping. Okay, we're going to break this down into VRV specific piping components. We're going to look at piping limits. Okay, we're going to look at piping installation. All right, so move on from there. In piping, specific piping components, the shortest part of this talk this afternoon. Okay, basically, we have RefNet joints. So RefNet joints, the first 2 images, the first one for a heat pump system, which only has 2 pipes in it, 2-pipe system, and a 3-pipe system where a RefNet kit will come with 3 RefNets in it. Okay, you'll notice the RefNets step up in sizes. You need to cut these back to the size piping that you're working with. Okay, don't go and push the piping over and leave the longer end in if you need to cut it back further back over here. It must be cut back to the size that you're working on. Okay, then we have multi-combination RefNets. These are used at condensing units. Okay, and then we have a branch kit. Okay, and these over here are used generally on heat pump systems. Okay, and just remember with these, I'm going to mention it again just now, that these over here must be installed horizontally. Okay, so branch kits are always installed horizontally. Okay. Okay, so piping limits. Okay, and this is something where there are many piping limits in systems. Okay, and I'm going to start off first of all with just a schematic, and just basically just to give you an idea, this schematic, okay, does not confirm compatibility. Okay, it is intended only to indicate the piping length limits. So in other words, you'll never come across a system that has all of these components in it. All right, it's not possible to install all of them together. What this is showing you is what the limits will be as we discuss some of them. Okay, now there are many, and I'm not going to go through all of them this afternoon, but what I'm going to make you aware of, some of the important ones, okay, and the need to update your installation schematics continually as you're installing, and bring to our attention anything that you start to feel as a problem, and particularly if you've got a schematic where the piping lengths have been entered onto it and you start to extend past those piping limits. Okay, we need to know rather sooner than later when that happens, because when we start going past those limits, we may have to upsize piping, and in some instances you may actually overshoot the total allowed piping length completely. Okay, so we need to make sure you don't go into those. So like I said, this is a schematic purely to show you, okay, what the indicated pipe lengths are, okay, the limitations are. Okay, so here that schematic is again, okay, and so we have an actual and maximum. Now we talk about 2 types of piping lengths here, the actual, which is what you measure with a tape measure, okay, and the equivalent piping length. Equivalent piping length being what we add up each elbow or each fitting, okay, and what that adds to the system. Now, if you think about a 3/8" elbow, okay, 3/8" elbow, if you take it as a straight piece of piping, is almost equivalent to 300 millimeters of piping. Okay, so although that little 3/8 elbow is you can hold it in your hand, its actual straight length of piping is quite a bit longer than it is. Okay, so we need to consider that, because that is what equivalent piping is. The more elbows you have in a system, the faster you're going to reach the equivalent length. Okay, and we need to try and remember that we need to reduce the number of fittings as much as possible. Okay, so the longest pipe run that we are allowed, okay, for VRV condensers, okay, these are the Vrv4 condensers, the vertical discharge type, is 165 meters actual. So that would be the measurements of A, okay, through C, okay, and B, and then right to the end over here, 165 or 100, and what's in brackets is the equivalent length, or 190 meters in equivalent length. Okay, one of the important rules to remember is the distance from our first branch. Okay, this is the first ref net, not the if any ref nets that you got at the condenser, but the first one on the indoor ref nets. From there to the furthest pipe run to any one of the units, no more than 40 meters. Okay, if you start overshooting that, you need to start talking very quickly to us so we can start having a look at the pipe sizes. Okay, this can also be rectified often by moving the ref net. Sometimes just moving it and having a slightly longer run of piping, maybe to this unit over here, and shortening the pipe run through to the last unit can often get us away from having to resize piping. And many times when it's happened on site and we've gone there, we've been able to rectify this through the help of the sales engineers and their software that they work on. Okay. Branches, for instance, between condensers, they're size D, no more than 10 meters. Okay, between them over there. Okay. Indoor to outdoor height. Okay, we're not allowed any more than 30 meters. Okay, you'll see that if you have an LT hydrobox connection, this is reduced to 15 meters. Okay, and outdoor to outdoor height, no more than 5 meters. Okay, total piping length up to 1,000 meters. Okay, in all standard combinations. Okay, and then non-standard and all multi-outdoor combinations, except standard, 500 meters. Okay, all right, and then of course, just get on to some other measurements, but we also can use RA units. These are non-VRV indoor units in conjunction with BP boxes. Okay, and these also affect, and I'm going to show you as we move on to one of the other slides, some of the things you need to keep in mind for that. Okay, here we've got that over here again, and something we need to consider here. We're looking now at something which has become popular, are our expansion valve kits, which connect onto air handling units. And when using these, we must also consider a maximum length between the kit and the unit of 5 meters, and a maximum height also 5 meters. So you cannot have 5 meters height and 5 meters of length. Okay, it's 5 meters combined. Okay, so you can either go up 2 and across 3, but never 5 and 5 and have 10 meters of piping. Okay, BP to RA boxes. Okay, that's this measurement over here, anywhere from 2 to 15 meters, but I'm going to give you a guideline for that as we build this up a bit further. Okay, you'll see here this is VRV, a mini VRV, and here you'll see the piping lengths also slightly different on there. Okay, the maximum indoor to indoor height of 15 meters. Okay, and a maximum length of 120 meters or less. Okay, 70 for the 4 and 5 horsepower, 120 for the 4 to 6, less than 100 meters for the 8, and 10 and 12 also for 120 meters. Okay. I said to you I was going to talk about the BP boxes. Okay, one of the other measurements that I want to bring to your attention that comes up on this slide over here is the measurement L5 over here, which is 5 meters. You must have in any system 5 meters of piping before your first indoor ref net joint. Okay, very important to remember. We do come across installations where they try to put the first indoor ref net very close to the condenser. The minimum pipe run there is 5 meters for that. Okay. And then the other one, the one that I wanted to chat to you about, was the length of BP boxes for indoor units with a capacity index of less than 60. Okay, so that would be like with a model number as a 60 in it or less. Okay, they must be or greater than 60, so they should be less than 15 meters. If it's equal to 60, 12 meters. Okay, and 8 meters for units smaller than that. Okay. All right, so this will be a typical schematic that somebody would build a VRV or install a VRV system off of. Okay, and what's important here, okay, when the pipe lengths deviate from the original design, consult your Daikin sales engineer sooner than later. Right, so in this particular schematic, there are no pipe lengths, but this is something that a person will have on site. They must have on site while they're installing, and they should be updating this on a frequent basis. So basically at the end of a day, they should be looking at how much piping they laid, and they can actually go and say, right, well, today we laid piping here, here, and down to here. We should now be able to measure that and start adding it up. Okay, and then they should start seeing whether they're hitting a problem on there. So very important from an installer's perspective that you keep these piping lengths up to date. Don't wait to the end to find out that you've overshot and that you now have to change pipe sizes. That's going to cost a lot of money. You should have a pretty good idea, if you've done all your planning, what your actual piping lengths are going to be, because by the time you get to lay your piping, you've probably put down your cable tray, and even just measuring that would give you a pretty good idea where they're going to be. Okay. All right, so what happens in the instant where we have to do a pipe size up? Well, this will depend on the total equivalent piping length. And the calculated capacity drop due to equivalent piping length from the first branch pipe size up might be necessary. There are many rules, okay, and limits for pipe size up. Consult the engineering data book for more details, or else chat to one of your sales engineer or one of the service engineers as well, and ask them as soon as you consider that you might be in a dangerous area. If the size up dimension is not available in your market, never size up once more. Use the original size without sizing up. Okay, and what this actually means is you'll see sometimes on some of the programs, they'll kick out a 1-inch size piping, and we don't do 1 inch in South Africa. We've got it's an 1 1/8 inch, and the next pipe on the other side is 7/8. If it's sized up from 7/8 to 1 inch, you don't go to 1 1/8. You just keep the piping sized at 7/8. Okay. All right, so on the piping, that was the limitations. Piping installation, it's the third part of what we're going to discuss this afternoon. And I'm going to start over here now with a video. Okay, this is a RefNet. See the water flowing equally there. The RefNet is horizontal. That's how we want it installed. Bubbles going through the mouth. See the effect of the flow of the system. Right, okay, so we use RefNet. It's a Y joint. Okay, some people call it that. All right, and we use it instead of T-pieces. T-pieces, if you consider yourself driving along a road and you get into a T-junction, okay, if you were traveling like refrigerant, you wouldn't know that that T-junction was there, and very often it would be a lot harder to actually make that turn, okay? So you find that for the target outdoor condition might be going down to -7, which is not okay. If you're not using ref nets and using T-pieces, the flow is not even in the system, okay? It's not equal, and this causes the system to have an unbalance of temperatures, okay, or imbalance of temperatures available, okay? So if we use ref net joints, this is what this symbol denotes over here, we get a much more even flow and our target condition of -2, which is much better. Okay, we spoke earlier on about ref net headers, okay, with a header joint. Remember, they must be horizontal, and this is what a typical ref net joint looks like. Okay, it's a Y joint, and it comes with its own installation. You're not allowed to do your own homemade ref nets like this, okay? These are not acceptable. And where we have found these in systems, we've had plenty of compressor failures because they are not designed properly. Okay. Also remember, we spoke and you saw in the video that the ref net, okay, must be horizontal. Okay. You can mount them vertical, but not turned up 90 degrees when the whole joint, okay, is in the vertical plane. You can do that. And then headers, as I said, only in the horizontal plane. So here you see a ref net that is mounted vertically. That is not acceptable. Okay. Your maximum angle is 15 degrees. And as far as I'm concerned, I don't know anybody who needs to mount something at 15 degrees. Aim for 100% horizontal with the ref nets. And remember that ref nets at the condenser, okay, must be mounted horizontal at all times, okay? All right, so there's no other way to mount ref nets at the condenser. They must be horizontal. When installing systems, it does happen from time to time that systems are installed in partial first and second phase, or maybe even third phase installations. Okay, you may not just extend the piping on the ref net and leave it blanked off. Okay, oil can go into this piping, and there's no way for this oil to make it back to the compressor, and you can damage the compressor. What we do recommend in this installation is that a ball type shuttle valve is installed, okay, within 500 millimeters of the ref net joint, and then the piping is continued after that to where the second phase installation is going to start. Okay, that valve can then be closed off, so can the piping. You can put a Schrader in here, and at the appropriate time we can evacuate just the section of piping, weigh in the gas charge for the piping, okay, and then we can open up the ball valve. Okay, remember, only ball type valves, these have a low pressure drop. Gate type valves have a high pressure drop, they're not acceptable. Okay, so just consider that when doing phased installations. Okay, some pointers for pipes. Okay, please make sure that pipe ends are closed at all times. Okay, either taped up or crimped and welded. Okay, this type of thing is not acceptable. The pipes are open. Here you can see even sand has got onto the pipes. Okay, and also something else, you're not allowed to cut pipes with an angle grinder, okay, or cutting disc, okay, as you can throw a lot of debris inside the pipes, both from the copper and from the cutting disc. If you don't close off piping and moisture gets into the piping, then this is the type of damage that can happen to a compressor. And here you can see that the scroll is actually rusted from the amount of water that entered into vertical piping that was not closed off on site. So very important that piping is closed off at all times. If you receive piping on site from a supplier, you're well within your rights to send it back if it traveled on the bucky and it was never closed up. Okay, and I've seen buckies driving around from suppliers with piping where the caps have come off. Okay. Right, some other tips for working with pipes. Okay. Right, when cutting pipes, use pipe cutters. And there we go. You may not use a Dremel or Dremel type cutters. Okay. must use a pipe cutter. Okay. All right. Also, when it comes to deburring pipes, some considerations that we must make. Okay. In the first video, you should not hold the piping up in the vertical plane upwards. Okay. When cleaning. All the material that you're deburring off of there is going to fall inside the pipes. Okay, and we don't want this traveling around in a refrigeration system. It's going to be deadly for compressors and other components. Hold the piping downwards, ensuring that any of the deburred material falls out of the piping. Some pointers of bending of piping. Okay, we're looking to get a uniform bend. Okay. Using a pipe bender, which should be used at all times when bending pipes. And this is just another type of pipe bender over here. So what are we looking for when we bend pipes? Well, one, like I said, we want a uniform bend. So we don't want to see any of these pleating, okay, or ribs around the inside of the piping that you would get if you bent it over your knees. Okay, we don't want to see that. We don't want to see any deformation or damage to the piping. So in other words, we talk about uniform. We want to see a diameter that remains the same throughout the bend. Okay, from the time it enters and the time that it leaves. We don't want to see the pipe kinked in any way or the deformed from a round to an oval shape. Okay, it must be constant in shape all the way through the bend. So that's the type of thing that we're looking for over there. Well, so that's sort of working with piping. One of the other aspects of working with piping is that we are required to braze, okay, to join sections together. At any time that you braze on a refrigeration system or a VRV system included in that, you are required to use nitrogen, a flow of nitrogen through the piping, okay, and that is set up through a regulator, okay, at not more than 20 kPa, 0.2 bar. Okay, the following rig, as you can see in this over here, is a nitrogen bottle with regulator, okay, and we then got a reducer fitting onto there, and we blow nitrogen into the pipes, okay, through the area that we're going to be welding, okay, at a low pressure, not at a high pressure. We don't want that blowing back through the weld and damaging the weld, okay, and then the piping must not be closed off on the end. The nitrogen must be able to flow out. And then, of course, it is also advisable on bigger pipes to tape up at least half the outflow so that we ensure that we fill the pipes up with nitrogen. Okay, a bigger pipe, we may only be having nitrogen flowing in the bottom, and that's not going to help the top of the pipe. We're still going to get oxidation there. Okay. So very, very important that Brazing, if you don't braze with nitrogen, the oxidation, the flaking that you get inside the pipes has a big negative impact on the oil and on the working components like expansion valves and things like that. And we also have a lot of strainers in the system. Okay, and those strainers can also block up. Okay, do not use antioxidants or do not use flux. Use phosphor copper brazing filler alloy. Okay, that's your normal copper rods. Flux has an extremely harmful influence on refrigerant piping systems. Okay, for instance, if it's chlorine based, okay, and it's used, it will cause pipe corrosion. And in particular, the flux contains fluorine. It will deteriorate the refrigerant oil, resulting in eventual component damage. Okay, so do not use rods that are flux coated or any flux material that you might have, like some of these that you have to paint onto the piping. Only use phosphor copper brazing filler rods when welding. In a system that is contaminated, what often happens is it damages the needle part of the expansion valve, okay? And this doesn't seat properly in the needle and seat operation. And expansion valves in today's environment, electronic expansion valves, seal off 100% in a system. Okay, so in a case like this, we'd have constant refrigerant bleeding through, and this could have a detrimental effect both in noise or in extended, the unit might carry on cooling if it's significant enough, or even heating. Okay, so we want this tip over here on the expansion valve to be protected. We don't want any dirt in the system. Okay, and in a non-clean system, this is the type of thing that we're going to see. Acid buildup as well over time in a system, if not dealt with, can also cause these surfaces to become damaged. So when welding with a system, it's important that we use the correct amount of filler rod and correct amount of heat. Okay, so here's a quick video. There are a couple of things that we need to be looking at while we're welding, and some telltale signs. When you see a joint that has just started to heat up like that, in other words, we've almost got this black and red type thing over here, it's too cool. Okay, if it's too hot, there's the orange part of it extends way beyond the joint that we're welding. What we need to do is try and keep the orange, the cherry red, okay, glow within the region of what we're welding only. Okay, so very important just to keep an eye on that. That's something that you can obviously, that experience will teach you, but it's just something to start watching while you're welding. Okay, what color have you got? And you don't want this thing over here looking like a Formula One racing car's exhaust pipe. Okay, it doesn't, we just need to keep it in this region over here. So when welding with nitrogen, what does it affect? Okay, in this video over here, we'll show, you'll see that the top pipe is without nitrogen and the bottom pipe is with nitrogen. And then I'm going to weld it. Okay. And immediately we can see the difference, okay, in the finish of the weld. And you can see there, some of the flux already started to break off as the weld started to cool. All right. Okay, so we don't want this inside the system. Okay, this is detrimental to any refrigeration system, and it will definitely reduce the life of a unit. When we inspect sites, it's one of the things that we can do. We can ask to cut open piping. And if we find that the piping has got evidence that it wasn't welded with nitrogen, this will affect the warranty of the unit. Okay. Something else to consider. Okay, here's a clean surface and a oxidized surface of this over here. And like, as I said, there are strainers in the system. Okay, and these strainers are very, very fine. If you've ever cut into a system and into one of these strainers, you'll see it's a very fine mesh, and these can clog up. And we don't want to have that happening. Raising methods, okay, that are not acceptable. Okay, you may not butt join. As I say, only butt join. Okay, but we over here, you cannot just push two pieces of pipe together and weld them. You cannot flare a pipe and weld it either. You may use a swage joint or a socket only. Okay, when joining two sections of piping together. All right, branch kits, just to get onto the rules of those. First of all, and believe me, we've seen this, okay, where guys, instead of using the inlet of the refrigerant into the Y joint from this direction over here, they come in from one of the two Y joints. Okay, you cannot do this. Okay, the Y joint is designed to spread the refrigerant flow evenly. Okay, as though you were driving down a road and you came to a Y section. It's a lot easier if you're approaching the two from the straight side. You can decide whether you want to go left or right, where if you're entering from over here, it's very difficult to come back and make a U-turn down here. So think about the refrigerant in the system as well. All right, so this goes over here. This is a diagram showing to the indoor units. Okay, so basically that's not the flow. Okay, this is at the condenser, for instance. That means the refrigerant in this joint is coming back this direction over here. Okay, and going to the master outdoor unit and then onto the sub unit. Okay, so here again, like I said, flow must always be in from this side over here. Okay, and then through the two through there. Okay. So those are not allowed. Yeah, okay, and this is the preferred one over here. Right, as we said earlier on, RefNet joints, okay, can only be installed horizontal. Okay, if they're in the horizontal plane, they must be, both pipes must be level. Okay, you can install RefNets for indoor units in the vertical plane, but here you see both of them must be in the same plane. Okay, you cannot do this. Okay, so just keep that in mind. Okay, here again, we've got this over here. The RefNet is horizontal. It may not be like that, where the pipe is one above the other on the branch. Guys, you get this right, because as much as we talk about this, we still come across sites where this has happened. Okay, some other pointers. Okay, we spoke a bit about this in the first session, but I said I'd clarify it again. Okay, any piping coming into a RefNet joint, the minimum straight piece of piping must be 500 millimeters. All right. Okay, so we've got 500 millimeters of straight piping coming in there between two RefNet joints. Okay, and these are looking upwards. Okay, if you're looking from the ground up, so these are not horizontal. These are, I mean vertical. These are horizontal. Okay, these RefNets must be a meter apart, minimum of a meter apart. You can have more, but you cannot have less than a meter. So anytime you've got two RefNet joints, don't come out of one straight into another. Okay, and at all times, any bends on the indoor units, okay, must have 500 millimeters of pipe. Okay, on there. You can use hangers, okay, and RefNet joints. Each joint must be supported by a hanger if you choose to use this type of hanger and not cable tray. What does that look like in a schematic form? Basically, this is what we're looking at over here. Any time on the indoor units, we must have the minimum of 500 millimeters of straight piping going in, a minimum of 1 meter between RefNets, okay, and a minimum of 500 millimeters of piping coming out, okay, and if you've got to a unit, minimum of 1 meter of piping. Okay, so you cannot come out and go straight into a unit. You need to have at least 1 meter of piping before you go into that unit. Another reason for using RefNets, and in particular on indoor units, is that when installed correctly, they reduce the noise flow through the pipes. Okay, because they break the flow up evenly. Okay, it's something that you won't get with a T-joint. You'll get quite a bit of noise as the gas swishes around through all those bends and everything. So we're breaking down and we're getting rid of the turbulence. Okay, that can be created, and that will always generate as or show up as noise. Right, we may not make U bends after ref nets. Okay, like this. Okay, this is detrimental because this actually transfers the force onto the wide joint in different directions. Okay, and can actually cause these wide joints to start cracking. So any time that a ref net is returned to us, and we see that and the guys tell us, oh no, it's leaking. Very often these things happen after a system has been running for a while. We will go to site and find that something has been done in the piping that caused the wide joint to crack. Okay, and this will be from expansion and contraction, and also from illegal U joints and things like that are not allowed in the system. Okay, expansion and contraction is easily identified when we have cracks in piping, and we see this type of cracking. Okay, it's a stress crack from where the pipe is being compressed and expanded, or under tension and compression. Okay, and eventually the piping will crack in that type of manner. All right, and that's we must consider as well that we are moving piping, and this piping can be going anywhere from 0 to possibly 75, 85 odd degrees. Okay, and that is a fair amount of expansion can happen when the piping. Okay, and you can get up to 1 centimeter for 10 meters in length over that sort of temperature range. It's quite considerable. Okay, and from time to time, you may be required to put an expansion joint to prevent the piping from cracking or ref nets from being broken. Okay, never rigidly support piping. Always allow for movement due to temperature change. Okay, so it's not an idea to clamp piping down. Allow for some movement, and the expansion loop that we're talking about is if it required a 30 centimeter by 30 centimeter loop, horizontal. Okay, and in systems you may have to put this in every 10 meters. Okay, if there's provision for movement has been or non-movement has allowed it. Okay, and this is the type of leaks that we're talking about in ref nets, where they crack in the wide joint. Okay, and that's obviously often a telltale sign. If you've ever picked up a ref net, you'll see that the welding is high quality. It's not likely to leak, and very often these leaks develop over time, and that's the giveaway that they didn't leak in the beginning, but they cracked over time. That will tell us that it was an expansion contraction issue in the system. Okay, so just consider if you need to use expansion loops, that is how they are to be installed. All right, the next thing, something that we've been pushing a bit in recent times, and this is pipe insulation, and it's marked in our installation manuals. Okay, and you'll see that, for instance, if you live in a climate less than or equal to 30 degrees and less than 80% RH, you can use a 5/8 pipe according to the Daikin spec. If you're in an environment with a greater than 30 degrees or greater than 80% RH, okay, average temperatures, then you should be using 3/4. Cape Town falls in the region of 3/4. In fact, I think most of South Africa, by the Daikin spec, falls in 3/4. What is interesting to note is what the SANS 204 states, and this is a South African guideline. For all chill water and refrigeration piping, conditioning, air duct work, and flexible ducts shall be insulated to limit the heat gain or heat loss to not more than 5% from the source to the furthest point of delivery on a system. Now, if you consider a system that might be operating, let's say around 75 degrees, 75, 80 odd degrees, that is in the region of about 4 degrees, the 5%, okay? Just keep that in mind, because we're seeing guys insulating pipes, the 1/4 inch and 3/8 inch armor flex. It's not acceptable even by our local standards. I think if you look at, we were quite shocked. We did some work over in Mauritius, and we saw that their spec there was 1 inch, okay? And it really looked very different. In fact, at first glance at the piping, we thought we were looking at chill water piping, and then realized, no, that was actually the VRV piping, because ours just weren't used to seeing such thick armor flex on pipes. Okay, so just consider that. The guys will always tell us, oh, but we can't get the size armor flex. The reason why you can't get it is because the suppliers have never had to order it. Okay, but it is a specification made in the SANS guide. Okay, and we should be looking at using thicker armor flex. The reason for that is that we have incredibly efficient machines. Okay, and then we go and throw half that efficiency away by not insulating the pipes properly. And that means that the units then draw more power. And often when the guys say, oh, but the units don't perform according to what your manual says, you can go and find that a lot of your heat gains and losses, okay, are through insulation or through poor insulation. So please take note of that. Okay, and then because here's a video of the guys installing the insulation. And make sure when you're installing the insulation that it's not torn, okay, and also that you don't over tighten the taping when you on the seams on the joints. Okay, you don't want to squish that insulation down, because there you create an area of loss against. Okay, so taping must not be to compress the insulation, but more just to join the sections. And I do see in some of the guidelines that they actually recommend gluing the sections as well. Okay, use the original insulation provided with all branches. So you saw an image earlier on of that. You may not go and use non-drip tape and things like that for Y joints or for ref nets. Okay, you must use the original insulation. Okay. And then just a guide over here for when you're taping up pipes, or when working on them outdoors. If it's going to be for longer than a month, pinching, less than a month, pinching and taping, and indoors, pinching or taping. Okay, and that's because of the environment. You need to consider what's taking place. If you're going to be leaving site and you look at an installation and it might be done, some of these residences around Cape Town get done over 2-3 years, then piping should always be pinched, okay, and sealed off, because taping will eventually come off in the weather. Okay, insulation tape eventually finds its way off. Okay, so that's the end of that section. Are there any questions? Everybody still there?
Yeah, still, yeah.
Yes.
Yeah, great, thank you. All right, so
Yes,
we're going
still up.
excellent, great. Right, guys, we're going to go on to the next section, which is wiring. Okay, and in the wiring, we're going to look at power supply. Okay, overview of the Daikin wiring. Okay, and then wiring limits. You just ask if you can just turn off your microphones there, please. Is everybody microphone off there? Okay. Right. Okay, so power supply. Okay, selection and sizing of wiring should be done in accordance with applicable legislation based on the information in the table. Okay, so every country has its own legislation regarding wiring, and so Daikin, not to circumnavigate that, says that we should be looking at our local legislation, but in accordance with the guidelines as well inside the Daikin manuals. Okay, so our legislation in this country is pretty good. The type of things that you'll see on the units, outdoor unit capacity, say for a 10 horsepower, is its rated amperes or run load amps, okay, 10.2, minimum circuit amps is 22, maximum fuse is 25, and the recommended fuse is 25. What do they mean by recommended fuse? Okay, well, we don't have to install fuses, and this has also become confusing. We've seen guys that have tried to install fuses instead of circuit breakers. Fuse is an old term, but by modern terms, we use circuit breakers. So when they say maximum fuse amperage and you select your device, you select a circuit breaker. In this case, for a 3-phase machine, you'll select a triple pole circuit breaker. Okay. And our units are 3-phase and neutral, designed for 50 hertz. with a voltage of 380 to 415 volts. All right, okay. When it comes through to the commissioning stage, I'll also just mention to you guys, that'll be in the next section of work that we look at, that does not mean that you're going to have one phase at 380 and another phase at 415. Okay, these are the nominal voltages. Okay, the average is only allowed to be 3% either side of that. Okay, so circuit breaker. Okay, this is something that you guys should all be familiar with. Okay, that is selected from the maximum fuse amperage. Okay, and the maximum fuse amperage is also used to select an earth leakage breaker if one is to be installed. Okay, power supplies. Okay, you must consult your local legislation. Okay, especially with multi-combination wiring. Okay, and what we're looking at over here, power supplies must be each unit must have its own power supply. Okay, so what we've got over here is a three-phase and neutral power supply. There must be a separate ground to the unit. Okay, and a circuit breaker. Right, you may not daisy chain power supplies between units. Okay, this is not acceptable. There were old installation manuals from days of VRV2 gone by where that was acceptable. It's no longer acceptable. Okay, one of the problems that you've got is that any fault current in one unit from something burning out or a fault can travel back through another unit. And we saw this in a job in Stellenbosch a couple of years ago where over a period of years with an old VRV2 system, they had eventually gone through a number of compressor changes and PC board replacements. And it actually turned up that the single circuit breaker supplying this entire network of three multi-combination condensers had actually taken so much of a hammering over the years from all the compressor burnouts that we actually had about a 50 volt drop across one of the phases. And this was just having a knock-on effect on PC boards that were being replaced in the unit. Once they separated the power supplies and put in new circuit breakers, never heard from the system again. Okay, so just consider that. You're not allowed to daisy chain power between units. Each system, as you see down here, must have its own three-phase and neutral and separate ground and separate circuit breaker and isolator for each system. Okay, so keep that in mind as well. Okay, it's not allowed to use a bigger fuse than the MFA mentioned in the engineering data book, okay, in the installation manual, and the fuse must be a C-type or slow curve breaker. Okay, using the wrong type fuse can create a fire risk. Right, so don't use oversized fuses. Okay, something we don't see much of in this country is earth leakage breakers, but if you're asked to use an earth leakage breaker, okay, it must be inverter compatible, okay, and the DC component as well, okay, direct current component, and those symbols are what you should be seeing on there. Okay, this is a model number for a device that's not available here, so don't worry about that. Okay, supply wires, okay, the MCA, okay, so we use the maximum fuse amperage for the circuit breaker. We use the maximum circuit amperage for selecting the field wiring. All right, and this can be selected off of SANS tables or off of the supplier tables for the particular wire. They must be in accordance with the SANS as well when using them. Okay, power supplies, the specifications of the cable depend on the length of the cable, okay, and the MCA or maximum circuit amperage value. Okay, cable dimension is calculated by an electrical company. In other words, electrical engineer should be doing that. Okay, and the PE switch must be connected directly to the units without switching in between. In other words, you're not allowed to switch the neutral and earth on a unit. Okay, so you only switch the three phases, the three lines, but you do not switch the neutral and earth at any time. Okay, cable type applicable to 300 to 500 volts, PVC sheath and PVC insulated multi-core, multi-wire, three-phase plus neutral plus ground. Okay, something that I'm glad I'm seeing a lot more of is separate earth cables pulled into units. Okay, on a lot of Surfex cables that come with the earth, that little earth wire that's in there is often not enough earth to protect a unit, and we need sufficient earthing, particularly with electronic components. So I'm glad that we've seen a lot more installations where separate earth cables are pulled in, and it is definitely a move in the right direction. Overview of the Daikin wiring. Okay. Daikin transmission wires use 2 core cables. They must be between 0.75 and 1.25 millimeter square cables. Okay, here we're talking about the communication wiring. Okay, and the bus topology should be applied. Star connections are not allowed. In other words, it must go daisy chain as we talk about it. You may not star off and go to another unit. Interesting, recently we had guys that had a problem on a site, and after much conversing with the guys, it actually turned up that their problem was a star connection. Okay, so star connections are not allowed. You'll hear guys tell you, oh, we got away with it. Yeah, we've heard guys get away with it, and then a couple of months later, suddenly they pick up a problem, and the system doesn't want to boot up after something happened, and then they've got to go and hunt for their star connection. So sometimes you can, so rather don't be a gambling person. No star connections, follow the daisy chain. Okay, don't allow for any of those star connections. They're going to come back and bite you. Okay. The installing contractor must assess the installation for possibility of noise interference on the communication and use shielded cable when necessary. Okay, so up until VRV4, okay, it has not been compulsory to use a shielded cable, but you will know that as we move, or when we do move into VRV5, it's going to become a compulsory aspect. It's in the training notes for VRV5 already. So my feeling about it is that if you are in an environment where you suspect that there might be noise interference on the cable, and this can come from fluorescent lights, it can come from X-ray equipment in a hospital or scanners in a hospital, Wi-Fi repeaters can also cause problems. Your voltage cables and your incoming power supply cables in a building, when you are installed very close to them, can be an issue as well. Rather use a shielded cable. Okay, and remember that with a shielded cable, okay, you only have to fix one side of the earth. You never installed or earth both sides of that cable. And I particularly want to just drive that point home. You must earth one side. Okay, so don't leave an expensive shielded cable with no earth on it. Otherwise, you might as well just have installed speaker cable. Okay, so the overview of the wiring. Okay, so this is a standard type installation. One condenser with a couple of indoor units. You'll see the F1, F2 in the outdoor unit. You will see F1, F2 in, F1, F2 out, and Q1, Q2. Okay, with a single compressor, we're not going to use Q1, Q2, but we have F1, F2 going to the indoors, and each unit has an F1, F2, P1, P2, T1, T2. And we then daisy chain through the F1, F2 loop in the following sequence. Okay. Where we have a heat recovery system. Okay, the same story over here, except this time we don't go to the indoor units. We're going to connect up onto the BS boxes. Okay, we have multi-BS boxes and we have single port BS boxes. And on the multi-BS box, you will notice that there are 2 connections, outdoor and BS. And this is where the guys tend to get it a bit wrong, but it's just something just to try and remember. Okay, you go from the F1, F2 indoor. Okay, so the outdoor unit is sending the cable to the indoors, but the BS box is looking back at the cable coming from the outdoor. So you know that it connects into the outdoor. The next connection is from the BS box. And again, if it went to a multi, it would connect onto another outdoor, and then BS would come out. In this case over here, it's going to a single port. It only connects onto the BS. Then each of the indoor units, okay, will connect onto the F1, F2 units marked according to the ports, A, B, C, D, and so on through there. Okay. BP boxes, okay, these are boxes used, they're expansion valve kits. They're not a BS box, they're a BP box. They're basically an expansion valve that allows us to use RA equipment. These are split type units that would normally have their own condenser. Some of them are compatible with VRV, but they have to be connected through an expansion valve kit. Remembering that in VRV, the indoor units have an expansion valve. Okay, when we talk about our splits or our sky air product, the expansion valve is in the outdoor unit. Okay, so what this box over here does is provide an expansion valve for the indoor. Okay, and you must remember that again the F1, F2 connects through any VRV indoor F1, F2 into the BP boxes F1, F2. That then in turn has a 3-wire connection. Remember your standard 1, 2, 3 terminology, okay, for splits. Will then connect onto each of the indoor splits. Can come off of that onto another VRV indoor unit on the other side. So that's just bringing you up to date there with the BP boxes. Okay. Remember at all times, one of the most critical things, and I'm going to go back a slide over here, okay, and then we'll come back to the slide as well. It's very, very important, okay, when connecting these up, okay, that your wiring for the A unit, okay, runs with the piping for the A port. Okay, if you start to swap these around on heat recovery systems, you're going to cause yourself a lot of nightmares. Okay, because what's going to happen is the signal, if 2 units are in opposite modes and their wiring is swapped, the cooling is going to go to the guy wanting heating, and this chap's heating will end up going to the guy who wanted cooling. And you're going to get a lot of nuisance calls until you get on top of the problem. Okay, and it's quite something to try and reset, because once the system codes up, it has addressed everything inside the system, and it takes a hard reset of about 45 seconds to undo this. Okay, and we've had cases where it hasn't been undone, and we've actually had to replace the PC board and the condenser. And it's not a warranty claim if it's a wiring fault. Okay, the same thing can happen with BP boxes. You've got also A, B, and C ports on them. Okay, and from time to time we found that these are being swapped around as well. So take note when you're installing, have a plan, make sure that your piping is accounted for on one port and that the wiring for that port travels with that piping as well. Okay. All right. Q1, Q2, what is that used for? Okay, well, that's the outdoor wiring. This is when we have more than one condenser. We have 1 or 2 slaves connected to it. And the Q1, Q2 also daisy chain from the master to the slave 1 and to the slave 2. All right. Okay, so just keep that in mind as well. These cables must be in. You don't need to put an F1, F2 into the sub 1 and sub 2 unit, what we also call the slave 1, slave 2. Don't do that. These units will now communicate, and because they are in this following configuration, these 2 units will hand over their control to the master unit or to the main unit. Okay. Other wiring in the outdoor unit is the F1, F2 out. Okay, this is where I'm going to plug my laptop into when I come to commission. All right, it's also where we plug centralized controllers into. And in this configuration, only the master unit is looped, okay, if we're going to use a centralized controller. Remember, this unit is already connected to here by Q1, Q2, so the information will be transferred across. So there we have F1, F2 out from a single to a single slave unit, and then out to a unit with 3 condensers, and then onto the centralized controller. Okay. On the indoor units, we've already discussed where the F1, F2 comes from. That comes from the outdoor unit, but all controllers, okay, are mounted on the P1, P2. It is possible to daisy chain multiple units onto one controller, up to 16 of them. Okay, keep that in mind. And the T1, T2 is used for card readers or window switches. It's a contact that can be used for switching units on and off or designating an alarm situation. So in hotels, they will put their card readers into here. When the person walks in and puts the key card in there, it will allow the unit to be switched on. When they take it out, the unit will be switched off. Same for window contacts. Anybody opening a window, if there is a window contact, the unit will switch off so that you don't waste energy. Okay, so remember with air conditioning, you either have air conditioning or you have an open window. You can't have both. All right, moving on to that, outdoor unit wiring connections. Typical, what you would see when you open up a condenser, you'll see that it's got terminals for the 3 phases and neutral, okay, as well as an earth connection point. Okay, that's not shown over here, but 8s, 10s, and 12 horsepower. That's where you will find the connection point, and then the 14, 16, 18, and 20 horsepower units, the connection point is over here, in this area over here. Okay. Supply cables must be terminated in a suitable ring terminal, ensuring an even grip under the terminal screw. You cannot just wind the wire around here and tighten it. Okay, it must go into a ring type terminal. Okay, that must be crimped and then fitted into there, okay, underneath the screw, and then tightened sufficiently. Okay. Communication wiring in the outdoor unit. These are found on the control PC board, the A1P PC board. Okay, and you'll find that on the 8, 10, and 12 in this vicinity of the wiring box, and on the 14, 16, 18, and 20, you'll find it over here, and the terminal strip in the bottom right corner, they're designating F1, F2 in, remember, going to the indoor units, F1, F2 out, going to a centralized controller or my laptop, or the Q1, Q2, which would connect to other condensers in the combination. Okay. Just some considerations. Okay, so we need an earth leakage protector, fuse, outdoor unit, indoor unit, okay, user interface, okay, and if you've got a personal computer or radio, something like that, okay, these things might require that you may need to use a screen cable, okay, interference. The unit can be also, these units can also, if you've got them too close, can interfere with your radio signal as well. Okay, so if you've got devices like that and they're crackling and all that, you can also find that the unit has ability to interfere with that. Okay. Right, so piping, what would a normal piping and cable bundle between the indoor and outdoor unit look like? Well, here we've got the liquid gas pipe with some insulation. There's some taping going over it. And then, of course, the communication cable over here, and finishing and making a nice neat bundle. Okay, and as I said, communication cable between 0.75 and 1.25 millimeters squared. All right, so don't use anything less than that. Don't try and use this telecom type wire and try and join up multi-strands of that. That's not acceptable. Must be a single core cable traveling on it, you know, basically in a sheath. All right, so, and it must be the diameter 0.75 to 1.25. Wiring limits. Okay, so the longest wiring, okay, F1, F2 indoor, okay, is 1,000 meters. The total wiring, okay, less than or equal to 2,000 meters, okay, less than or equal to 128 indoor units per outdoor system, okay. And it is possible to operate without a remote controller, provided there is a centralized controller. And we've done this before. At commissioning, though, we had to have a set of remote controllers installed. And once commissioning was done, we then connected up a centralized controller and took the wired remotes out. Just a point which is something to consider when this happens. It is always nice to have at least one wired remote somewhere in the system. Okay, it's easier to access the system and to see any faults, even if this was just tucked up inside a ceiling near a unit or something, and something is sort of marked that people know where to go to find it. Okay, so here on this particular system, you can see we've got an indoor unit. You can see the typical F1, F2 loop going through. You can see the outdoor units looped. Okay, and we've got some controllers as well. So you can see units that have got multiple controllers on them. Okay, like that over there. Okay, we can connect up our ventilation type equipment onto there as well. VAM units. Okay. And Sky Air units can also be connected onto this. And Sky Air units have their own F1, F2. And in the case of this, okay, the daisy chain would then run to the F1, F2 on the indoor, remembering that Sky Air, the F1, F2, if they're going to use it, is merely a communication cable, but it's just there to be for the centralized controller, and that is found on the indoor units. Okay, control wiring of the ventilation equipment. The sky air can either be on the F1, F2 indoor or F1, F2 outdoor line. Okay. Right, and as we said, keep in mind those wiring limits there. Okay, maximum of 10 outdoor units may be connected to the same F1, F2 outdoor communication line. Right. Okay, and the wiring from the outdoor 2, okay, line 1, okay, must be less than 10 meters, okay, and from the last outdoor to the controller, less than 200 meters. Okay. Remembering that when you're doing this type of wiring as well, especially to centralized controllers, it is advisable, because this wiring does get long, to use a screen cable, and to remember that you always need to earth at least one side of each section of that screen cable. Okay, just keep that in mind, because it'll save you a lot of heartache in the long run. Okay, so question session 3. Are there any questions? Everybody comfortable? You all still there?
Yes, we are.
Okay, great. All right. Okay, so we're going to go on to the next section, and this I'm going to just touch on this week. We're going to look at pressure testing and evacuation of the system. It's after you've done the piping and everything, you need to do a pressure test, and then system evacuation. This is often where systems, we pick up some of the biggest problems. Okay, and let's just go through the pressure testing. Okay, we're going to look at mode 21, vacuum recovery mode. Very important mode to know when working with VRV. Okay, can be used for solving a lot of problems, and then vacuuming a system. Okay, so pressure testing. System installed like that. Okay, and you laugh. I haven't seen one as bad as that, but I came across a cold room once that had been installed with Connex fittings. Right, plumbing type fittings. All the refrigerant had leaked out of the system over a period of time. It's crazy to think that somebody would even think of trying to install a unit like that. No? Definitely wouldn't have passed the pressure test. Okay, so the first pressure test refers to a pressure test while in the middle of piping installation to check the condition of pipe shafts and after pipe installation is finished and without indoor units. Okay, and the pressure test while indoor units are on the piping line is called the second leak test, and the final pressure test is before commissioning is called the third leak test. So what we're trying to encourage here, okay, and a very good way of working, is that as you're doing piping, you are crimping the piping off and pressure testing sections of piping. So you're going to say do the shafts, pressure test all the piping in a shaft. And the shaft piping might run over a number of floors, so it's quite a long section of piping and can often be very difficult to get into. Okay, so you're going to pressure test that, and if you've got any problems on that piping, you'll be able to know that you only need to look for a leak in that area. Okay, if you jumped and you missed leak test 1 and 2 and you only did leak test 3, you might end up looking at a number of floors of piping, which is going to make finding a very small leak very difficult. Where if you pressure test your piping, say at the end of every day, if you work and you can get a fair amount of piping in a day, then the next morning you'll very quickly be able to ascertain as to whether you actually have a leak or not. Okay, so it's very important. And what I have seen guys do is that when they've completed installation and they know that they're not going to be commissioning for some time, they put the system under pressure, okay, so that when they come back, they're able to see, and then you're getting a pressure test over a much longer period of time. What is very important about any pressure test is to log 2 things. First of all, the starting pressure and the starting ambient temperature, okay, and then when you come to checking, you need the final pressure and the final ambient temperature. So just keep that in mind, because a lot of guys come and tell me that they've done a pressure test, and I ask them what the starting and finishing temperatures are, and they can't tell me. So very, very important that they do that. Okay, so when we're looking at this over here, we're looking at that type of arrangement. Okay, so we've got gas and liquid pipes. They've looped out the piping just temporarily, and they've pressurized just this piping for the indoor units, okay, without the indoor units connected. All right, and then they will leave this on, and they'll be able to tell any leaks in there. They're only looking for a gas leak or a leak in that section of piping. Okay. And again, all of these pipes are brazed. Okay, don't ever try to do a pressure test with hose clamps or anything like that. Okay, type of pressure tests when you're doing pressure testing. Okay, you never ever take it straight to the maximum pressure first up. Okay, you always apply 0.5 megapascals. It's a rough check. Make sure leak nuts, flare nuts are tightened. All the joints have been welded. It does come across sometimes time when you're doing installation, you forget to weld the joint, it'll pop open. At least you haven't lost a whole lot of nitrogen and caused a massive pressure explosion if you went straight to 4 megapascals. Okay, then you take it to 1.5 megapascals, another rough check on each of these over here. You should be walking around the system, listening for leaks, going over joints. One of the things that's always important to do as well is maybe when you've got long runs of piping, to use a different color insulation tape over the joints so that if you need to go find them at a later stage, you know where they are. Okay, just to mark them off. Okay, and then your final pressure, no more than 4 megapascals. You'll see that we recommend 35 bar. This is 40 bars, so don't ever go above the 3.5 megapascals or 4 megapascals, but minimum is 3.5 megapascals or 35 bar, because that's a pressure test. And what I do recommend is that you take your gauge, and I always put a piece of masking tape over mine, and then I write on that masking tape the starting pressure, okay, and ambient temperature. So when I come back there, it's there. Take a photograph. Most guys got camera phones today. Take a photograph of it. All right. Okay, record your outdoor ambient temperatures and your end pressure testing. Okay, and you can use this formula here to work out the delta P max. Okay, then release the nitrogen. Okay, prepare the connections for the vacuum fuel piping. This is obviously after you've installed all the components. Stop valves, always be aware of what the stop valve should be, okay, and that you should never open the stop valves until you've completed pressure testing and evacuation. Okay, and then they'll always be turned fully in. Okay, and you'll also notice that on the new VRV4 Plus units, there's no longer a brass cap on the end, there's a plastic cap. Okay, these valves seat on both a taper and an O-ring. Okay, so they deem that they don't need the brass cap anymore, but you are required to put the plastic cap back on. Okay, and this just prevents dust and moisture from getting in there and starting to cause corrosion and eventual failure of the seals. Okay, so just keep that in mind. Okay, you can use core depressors. I'm a bigger fan of using core removers. Okay, so this is just something that's in the training material, but core removers are a much better way if you're coming into the point where you're now going to start doing an evacuation. Okay, also understanding, okay, there's those plastic caps in the VRV4 Plus. You see them over there. Okay, and this is just giving you an idea. Those are now valves that are in the closed position. Okay, so just understanding where they are, what they look like. Okay, these valves are the pipes that connect to the indoor units. This valve on the side is used for trim charging the machine. Okay, those are core depressors. As I said, I would rather use a core remover, and I've got a video which I'm going to share with you guys now, and we'll go through that after we've gone through the recovery mode. Okay, so recovery mode, very important. It lies under mode 2. Okay, mode 1, to get to mode 1, you just push BS1 button. Okay, this is on the control PC board. Okay, and you'll see a video of how to get to it. Mode 2, you actually hold down BS1, okay, and then you tap up to 21 times and you'll get through there. But I'll show you the video now, which is explains it a lot easier. Okay, so I'm going to hold down BS1 first, get into mode 2, and then BS2 until you get to 21. BS3, 0, BS2 to 1, and then twice on BS3, and the unit will come up tier 1. When it shows you tier 1, you can go check your indoor remote controllers, okay? And all of those should show that they're in test mode. Okay, then they're locked out. You can't do anything to them when they're in that mode. When they like that, okay, then all the expansion valves in the system, including the BS boxes on a heat recovery system, will all open up. Okay, and you can now perform a recovery pressure test or evacuate the system. Okay. All right, so very important to remember those. Okay, vacuuming. Once we've got it into mode 21, and we're going to evacuate the system, you need to remember, okay, that starting the vacuum, all right, we need to get down, okay, and we ask for a vacuum of 500 microns, okay. We also do a triple evacuation where you can come down in steps and you break the vacuum with nitrogen. You do not need to break it to 35 bar, okay. We're just using nitrogen basically just to pick up a bit of the moisture, but a much better way of clearing moisture out of a system is using a nitrogen purge, where you basically blow nitrogen through the system on a low pressure around 20 kPa for anywhere up to 30 minutes, okay, just to try and move out any moisture that's in vapor form. Moisture that's in the system as a liquid is another problem. And this will often hamper a vacuum, and if we suspect that there's that type of moisture in a system, you may have to start cutting pipes open and blowing through to find out where it is. All right, so I've got this video. This video is done by an American training school, but the video, I think the workflow in it is excellent. It shows the components that you need. He's got a very high-class vacuum kit, which we've actually used ourselves and found it to work. And so I think just keep an eye on the video and keep an eye on the way he operates, the way he works. And if you follow this type of procedure, you'll find that you'll be very, very successful in attaining vacuums.
All right, so it's Jim Bergman out here with TrueTech Tools, and we're going to go through how to do an evacuation. I had a friend of mine setting up a system today, so we just stopped out and we're going to go through and actually perform the evacuation and show you guys how to set up the evacuation kit, and which we have right here. We're going to show you how to get that thing set up, and we're going to show you how to properly evacuate the system. So what he's got here right now is we got the system. These are his gauges set up, and he just did a nitrogen sweep, pushed the air out of the system, has it on a standing pressure test at a couple hundred PSI. It's sitting here ready to roll, and we're going to go ahead, we're going to hook the blue back up to his pump. We're going to test his pump first to make sure his pump will pull down to below 100 microns. No power yet? Let's see. There we go. All right, so we got a small amount of night log already put on all the fittings on here. We're going to go ahead and we're going to test this pump out and see how far down the pump will pull on its own. All right, so the pump's already down to below 17 microns, 15 microns, 14. So the pump is very adequate for doing what we want to do. So let's go to the next step. Pulls down 9 microns. All right, so I was fighting these core tools, getting them on here because there's just not a lot of access the manufacturer put in this unit. So what I had to do is take the 2 screws out of the bottom of the service valve here and just lift this up a little bit to get it in there, because you want to be able to pull these cores out, because the cores are a huge restriction when you're doing your evacuation. So now I got the core tools open. I'm going to go ahead and pull the valve cores out. Got it on there seated. One of the key things you want to do here is you want to make sure you're keeping everything clean while you're doing this. So that's out. Pull that out, make sure I grab my core. So now what we're going to do is we're going to go ahead and we're going to hook up the core tools, or the evacuation rig to the pump, and Just like grabbing that bit. We've got a tree we're going to put here on the top. Tighten the T up. We've got our larger hoses here. And again, we just keep everything capped so it's clean. Heat right now. Now it does take a second longer to set all this up, but we're going to save a tremendous amount of time in our evacuation speed. So while we're putting a little bit on the front end, we're going to save quite a bit of time on the back end with getting this down here. Alright, so now what I'm going to do, pull this guy off, and I'm going to pull the rest of the pressure off the pump. Now the only thing we got left to do here is hook up our micron gauge. So I'm going to hook right to the port of the side of the core tool here. Alright. Vacuum pump. And I'm going to slowly crack this valve here and let it handle that pressure. Alright. And now we're good to go. So that'll start reading at about 20,000 microns. $3,000, 2,000, 900, 800, 700, 6, 5, 4, 3, 2. Now, obviously, as we get a deeper and deeper vacuum, it's going to go slower and slower. But right now, it's been running for less than 5 minutes, less than 3 minutes probably, and we're at 200 microns with this pump. So we're going to let this run a few more minutes, then I'm going to isolate the core tools, and we'll see what our vacuum, how stable our vacuum is, and where it levels off at. But you can see how quickly we can get down below 500 microns. The important thing is now is that we do a standing pressure test and let this sit for a minute, make sure that we're not having any problems with outgassing. I'm going to valve off my 2 core tools, and we're going to let that stabilize. So now there's no vacuum pump on this. You can see right here, here's our leak rate. We're at 0.6 microns per second of rise right now. We're holding right there at 296, 297. We're gonna let this run a little bit longer, and we'll just pull this down just for good practice. see our leak rate indicator showing we're at about 0.6 microns per second. So, you know, it's slowing down, and that's to be expected. The deeper the vacuum gets, the harder it is to pull. So we're at 216, 15, 14. You can see that's still dropping off. That's exactly what we'd expect to see. The deeper the vacuum gets, the slower we're going to go. We're at 212 microns right now, and typically this is what we consider a good finishing vacuum. So we're gonna give this a few more minutes to run, and we'll see where we end up at. So now our indicator's at 0, which means we're not making any progress. Right here's where we stalled out at. We've been on here for about 10 minutes or so, and we're not right. So we're gonna go ahead and say this is good to go on here. Now I've got the core tools isolated right now, and what I don't want to do is I don't want to take my micron gauge off yet, because I don't want to introduce air into the system. Because if I pull the micron gauge off, we're going to pull an air right to the side of the core tool here. So I've got these two closed. I'm going to go ahead and shut off my pump, and we'll disconnect our two hoses here. That's the looking one. Yeah, can't get to the big one. All right, so now we're going to just crack this service valve open here. Oops, get it all the way safe there. We're just going to break the vacuum. And once our gauge is high pressure here, we're going to take it off. All right, put the cores back in.
Okay, so that was basically a video on the evacuation. What I enjoyed with the video is that he's got a very good work routine. He's got a method to what he's doing. And I think that's where we see guys come short, is when the guys don't fully understand what they're trying to do. They don't have a method, they don't have a routine, and they just basically just never seem to be able to get vacuum. So that basically brings us to the end of that section. And I was asked, are there any questions? Okay. Well, gents, hello?
It was great though.
Hi, go ahead. Okay, all right. Okay, I take it that there's no questions there. Okay, so I'm going to just thank you for your time this afternoon, and I hope you join us next week for the last session of the installation, VRV installation training. Thanks a lot, and have a good evening, gents. Cheerio.
Cheerio, thanks.
Thank you.